Okay, hello students. Once again, I would like to welcome you all in this first practical lab, which is related to the linear regression training by using the single variable, right? So I again welcome you in this platform, HPC for Asia platform, where you will learn the, number of labs without having, any physical instructor. You can follow the steps of this video and you can learn the coding related to the machine learning. So today we are going to write a Python code, and in this lab we write a Python code and we will go to predict the house or home prices using the machine learning technique called the simple linear regression with the single variable. This is a very simple lab for the starters who are trying to start the, working on machine learning related things. So in this lab, I have, here you can see, if I show you, I have following, the table, and I have home prices based on the areas, and this is basically related to, let's suppose it's my hometown, and uh, in my neighborhood there are lots of homes which are in Sakhar township. Let's suppose we have some houses and we have some, the information about their area and the price. So based on this data, I will build a machine learning model, and we will build basically a machine learning model that can, tell me the price of homes. Let's suppose 3,500 square feet or 400 square feet. So you can uh, plot the prices and the areas in the form of scattered plot also. Let's suppose here you can see this is basically the previous uh, area and the price plot. I'm plotting, the area and the price here. Let's suppose we have the area of 2,500 and our price is something like that. In previously we can see 4,30,000. So 4,30,000 price you can see in this point. And if we have area, let's suppose 2,900 square feet, then our price is something like that. It's near to 5 lakhs and 70, or maybe something like that. Yeah, 5 lakhs 65,000. So this is basically all the points, data points we plotted here. And along with that, we have the blue line. You can see there is a blue line, and now we can draw this blue line which best fit the data points. What does it mean? Basically it means we are trying to predict the new prices by using this blue line. How we are predicting by using this blue line? If you can see, if I want to predict the 3,500, you know uh, the house which is having 3,500 area, then what will be the price of that? So if we can see the where this point can meet, it will meet something like that, the 6 lakh 13, 1,369. This can be the predicted price by using this blue line. So this blue line is basically is a best fit where we can get some data points for prediction. Now the question is that how this blue line come, um, and how this blue line we can draw uh, by using some equations. As I said in my previous introductory video, in machine learning we have some sort of branch which is called the deep learning and the mathematical, models. So here we are using some mathematical equations. You know about the linear equation, you learn about the linear equation. So we basically draw this line by using the linear equation, because there are number of ways you can draw this line, uh, but we can draw this line in a linear by using the linear equation. So your question maybe is this, that why not we can draw this line in this way, like green or red, why it should be blue? There is a certain mathematics behind this, as I said, the linear equations, and also some derivative and uh, um, derivative related equations behind this mathematics. So once we have the data points, then what we do, we calculate the error from this point to the newly new point, which is related to this blue line, or maybe red line, or some orange line or green line, right? So that we are trying to draw. So how we take this blue line, because we, on all the data points, we calculate the error rate, what will be the minimum error rate, and that error rate we are calculating by using this formula, where we have the y of change in the y of I, and the original y of I, we will minus the change in the y of I, basically by using the derivatives. So I'm not going into the details of this equation, just to understand that how we get this blue line is, basically we get this blue line when we minimize the error rate from this data point to here, and all the data points to this newly predicted data point, we minimize and we combine all the you know data points, and we will get this blue line. So this is how basically we get this blue line. So we calculate the as I said, the delta means the change in this from this point to this point. So then we average it and we square it by using the some this formula. So in this way we calculate the uh, and we repeat this process until our till the last our data point. So we do this procedure for all the lines. So for orange, or you can say green line, or red line, and this blue line. So we repeated the same procedure, and we found that this blue line is giving us the minimum error rate by using this formula. So I'm not going into the detail of the uh, mathematics of this. I hope you understand, or you learn in your AI or machine learning classes. Hence I choose you can say the line. Now if I remember my algebra class, we have some equations like this. So I got this from this website. So you can see here we have a slope, which is called the m, and we have the intercept, which is called the b. And here we have two variables like the price and the area, which we have currently in our data set. So in our data set, we have two, variables, two values. One is the price and another is the area. And we have to find out what should be the slope of and what should be the intercept when we are trying to predict a new price. So by using this linear equation, we can predict. So I hope you understand and you have the understanding of how we can use this linear equation in your theoretical classes. So moving ahead, this y basically is represent as a dependent variable, and this x is basically representing as a independent variable. So this x is basically our, you can say, the area, and y is basically our predicted price that we are trying to predict in this equation. And by using this linear equation formula, when we minimize the error rate, we will get the some slope or gradient, or you can say the coefficient, and we can also get the intercept, through which we can calculate the new predicted the y, means the price. Okay, so that's basically the theoretical part. Now let's move to the some practical part, and we are going now to write the Python code by using our HPC platform. Let me share the screen first. Okay, yeah. So this is the overview of our lab. Here you can see this is the first lab, linear regression single variable lab, and here our data set. that we are going to use, similar that I showed you on my presentation. So what you have, what this is basically the overview. What you will learn from this, tutorial or lab, you will learn about the Jupyter. You will learn about how to import the libraries and data frames, create data frames, plot the data points, and about mainly about the linear regression model, how you can train the linear regression model and how you can predict the price. And these are the things. So now the second step, what you have to do, you have to watch this video which I am going to record here, and I will give the ID of that video here, and you will, when you will access the platform, you will have this video available here, and you have to watch here, not you have to go on YouTube. You can directly watch the video here. So now the first thing that we have to import libraries. First, we have to utilize the libraries, and most important library is basically the sklearn. So I am going to, import here the libraries, some of the libraries. One is the Panda. I'm going to create its object PD, and another is the NumPy, another is the matplotlib, by using the PLT object. And the most important is sklearn. Sklearn, or this library is most important, through which we can import the linear regression model here, right? And the Panda is basically the very, very, useful library for, managing your data sets and managing your uh, data frames. And whenever you are playing, whenever you want to play with the data set, you have to use the Panda. It's very popular and very useful for machine learning related things. NumPy is basically when you're managing the huge number of arrays and all these things, so you can use the NumPy array. And matplotlib is basically to plot the, your data sets, and you can plot your, like as I showed you, the lines and all these things by using the matplotlib. And another one is basically the sklearn, which I told you already about it. In the first step, we have to import these libraries. In the second step, we have to create the data set. We have to import the data set, and we have to create the data frames. By using Panda, we are reading the CSV file that's available here, as I showed you before. So we are going to create the data frame here, and if I run this, first we have to run this in the first step. After running this, then you have to import the CSV file, and you can see your data is imported here in the data frame. So once your data frame is available, now the next step, what you have to do, you have to plot the data points, which I showed you before in my presentation. So how you can do it, you have to write the matplotlib inline magic. This is very magical thing. Whenever you are, plotting any data points or anything else. So at the PLT, we are giving the X label as an area in square feet, and the Y label we are giving as a price in USD. And we are plotting the scattered plot, where we use the DF, this, data frame, and we plot the price, and we give the color as a red, and we give the marker as a plus. So if we run this, you will see the plot is here. These all the data points you can see here, right? So this is the third step that you have to perform. In the fourth step, what you have to do basically, you have to create a new data frame, and where you have to drop the price, because we are going to create a X. If we check the formula, our formula is basically y is equal to x, sorry, y is equal to m into area plus b. So x is basically our coefficient or slope, b is basically our intercept, and area that we are giving is now basically the area that we have to separate from the price, because we want to give the area and y, and then we can train the model. So to train the model, what we have to do, we have to we have to drop the column price because we only want area, and this new data frame we will use to train the model. And also first we drop the you can see here you have both in data frame we have both columns, area and the price. But if we rewrite the new data frame and you will run this, you will have only area. Similarly, on the step 5, what you have to do, you have to uh, you know create a new data frame of price, and you have to run, and you will only have the price data frame, right? So now we have separately in new df we have area, and in price we have all the y information is available, means the price information. Now we are going to, in the sixth step, what we have to do, we are going to create our regression model. So how we will create the regression model, we will use the uh, our object that we created on top of linear regression model dot linear regression. We add this, and then you in this object we have added the linear regression model. And then when you run the new data frame, means that uh, your x is here and your y is here. So we are going to train the model by based on the our data x and the y. Basically the x is area and your price is basically the y. So we are going to train this model. Now your model is it's trained. So because of small amount of data, it's going to train very easily, and there will be no any huge time it will take. Now, after training, what we have to do, we have to predict some price, as we discussed in our presentation. If we want to predict, 3,500 square feet area, then what will be the price? So here you can see its price around similar, which I showed you in, my presentation. It's 6,13,369. So, and if I want to predict the another 4,000, so it will predict something like that, 6,74,374. Now our model is ready, and it is going to predict the uh, prices based on the given area that we want to predict. So you at the eighth step, you have to predict the 4,000 area, given area. Now what we have to do, uh, we want to see basically that what is the coefficient value that it calculated based on the equation that we discussed before, based on the error rate, minimizing the error rate. What is basically the coefficient value? If we write reg, means our model, and we dot coef underscore, then you will see your coefficient values. This is basically our coefficient value. And similarly, if I write reg dot intercept underscore, then you will have the intercept value also. So what is basically the formula that we were discussing about? Y is equal to m, means the our coefficient, into the x or area, you can say, plus b, right? So this is basically the formula. So how we can write, if we want to predict the previously 3,500 in this area, so it means it should be our coefficient multiplied by our prediction, that the area of our prediction that we want to predict, and plus our the intercept. So if we run this, and we can see same, hopefully we will see the same thing, right? 6 leg 1,300 and same thing like this, right? So now we have the coefficient and we have the intercept. So by using these, we can predict any new you can say the price of any home if we give the, you know, the if we give the area of that home, and then we can predict it. And in the final step, if I have to, draw the plot along with the blue line that I was discussing before with you, we can see here, hopefully, yeah. So this is the blue line we can, draw in this way. Similarly, after a scattered plot, you can see that we are, giving the area and our predicted, uh, new, the data related to the new data frame, right? So here we can see, we can, in the 12th step, you can draw this plot along with the blue line as well. So this is all about how we can, use the linear regression model. We can train the linear regression model, and we can do the prediction based on the single variable. So now after this lab, you have exercise here, right? So this is Canada's, per capita income in the year. What you have to do, you have to predict. If I give the year here, you have the 2026 to 2016 data you have available. And if I want to predict what will be the, future prediction, means 2020 or 2022, if I want to predict what will be the per capita income of the Canada in future, in particular year, 2020 or 2021 or 2022 or 2023, then it should give, the output. So after writing that file, you have to submit or send that file to your instructor, and then your lab exercise will be completed. So you have to perform this exercise. It's similar like this. So you have to perform this exercise. Okay, the next video, now just we are going to, having a very good lab in which we have more complex, linear regression model example. Currently, we use the single variable, and the next example we will use the, more variables. Like currently, we are only using the area to predict the price of the house. In future, in the next video, we will use the multiple variables, multiple x variables, right? In our to predict that, to predict the price of the house or some other things. We will use more variables, multiple variables. And that's all about today's video. I hope you understand. Thank you very much.